Sigma-Kellians! Good day! Welcome back to SMAPI Mathematics Club video channel, the tutorial and educational video program in the field of mathematics in junior high school. In this video, we are talking about the greatest common factor and the monomial common factor, a preparation for your lesson in grade 8 lesson on first quarter, which will be able to demonstrate the understanding the basic concepts of arithmetic through common factor of the set numbers and monomials. Before you watch this video, you can like, follow, and subscribe our YouTube channel of the SMAPI Mathematics Club. And if you like to watch our video on Facebook, you can like and follow the official Facebook page of the SMAPI Mathematics Club at www.facebook.com/SMAPIMathClub. Let's start! Today, students, we will have our short drill before we start our tutorial proper. So, let's identify what are the common things in every group of objects. So, let us start with a group of objects. We have the group A and group B. So, I would like to ask a question. So, what are the objects that are common to group A and group B? Right. So, these are the objects which are common both to two groups are notebook, ball pen, and cell phone. So, these are the three objects that are common both to two groups. Students, is that easy to determine objects which are common to each group? Of course, yes. So, let's relate and connect this with our lesson for this video tutorial. Students, today we will discuss the definition about the GCF or the greatest common factor. When we say greatest common factor, it is an only number which are common among the set of numbers which are already expressed as the factors or a products. For example, we have finding the greatest common factor of two numbers. The first example, which is 6 and 10. Okay, so before you going to find the GCF of two numbers, so we have to going to copy these two numbers. We have the 6 and 10. Next step to do is, so we are looking for the possible factors of two numbers. So let us apply using the prime factorization. So again, when we say prime factorization, it is the process of factoring numbers who are expressed with prime numbers. So let us start with the first number, which is 6. So what is the prime factorization of 6? Alright, so the prime factorization of 6, obviously, which is 2 times 3. Because 6 is divisible by 2, that satisfies the condition which is divided by 2, which is 3. And only 3 is divided by 3, which as the quotient is only 1. So we have the two numbers which are divided, whose number is 6, which is 3 times 2 or 2 times 3. How about the second number? Alright, so the possible factors of 10 are 2 times 5. 2 times 5. Okay, next, students. Is there any common to their two numbers of the following factors? Yes or no? Of course, yes. Why? So, in every factors of the given numbers, there are only common numbers here. So, what is the common of the given two numbers? So, the answer is 2. So, there is only 2 on 6 and 2 on 10. So, we have to find our common factors. So, now, our GCF right now, which is 2. Did you get it, students? How about another example? Number 2. we have to find the GCF of two numbers 6 and 15. So again, we are looking for the possible factors of two numbers 6 and 15. So again, we write the two numbers 6 and 15 and we'll be going to express as the factor forms using prime factorization. So let us start with 6. So 6 is divisible by 2, so it could be possible. So 6 divided by 2, which is 3. So which is 2, the first number. Next is, other factor of 6 is of course 3. So obviously 2 times 3 is the factor for 6. How about 15? So 15 is divisible by 2? It's not. So next to prime number, so 15 divided by 3, it could be possible. So 15 divided by 3 is 5. So we have 3 times, the only one number left is 5. Okay, so what is common of these two possible factors of two numbers? Alright, so we have the common there, which is 3. So circle, only one is 3. Okay? So thus, the GCF of two numbers, 6 and 15, which is 3, that is the circle 1. How about for letter C, or the third example? We have 24 and 36. So we have the same procedure or process here. So, do you have any idea how will you express factor forms of two numbers? Yes, so I have already discussed yet. So same procedure it is. So we have to rewrite numbers here. Then we will be going to express into prime factorization. So 24, it could be divided by 2. So it remains by 12. So 12 is also divided by 2. It becomes 6. So 6 is also divided by 2. It becomes 3. 3 is divided by 2, cannot be. So let's proceed to the next prime number, which is 3. Okay, so 3 divided by 3 is also 1. So 2 times 2 times 2 times 2, or times 3. Next number, which is 36. So 36 divided by 2, it is possible. So which is quotient of 18. So we have to write 2. The next is, the remaining quotient is 18. So 18 could be possible by divided by 2. So it becomes 9. So 2. 9 is divided by 2, cannot be. So proceed to the next prime number, which is 3. So 9 divided by 3 is equal to 3. So there are only left prime number is also 3. So 3 times 3. Okay? Is there any common here in the given two numbers of their possible factors? Of course, yes. So we'll determine the common factors of two numbers by encircling the common. So by which is that alignment. So that they are aligned with each other. So don't have their common here. So only 1 2's there, the another 2's, and 2 and 3 is not common. And 3 is also aligned with their common factors. So now, how can you express into GCF in product form? So thus GCF, you have to copy this, the box there. So the box common. So there are only 2 times the another 2 times the another box is also 3. Okay, so GCF is already expressed in product form. So we'll be going to simplify the GCF right now. So 2 times 2 equals 4. 4 multiplied by 3 is equal to 12. Thus, the GCF of two numbers 24 and 36 is 12. Did you get it, students? Okay, class, let us discuss about the CMF or the common monomial factor. So when we say common monomial factor, it is a monomial which are common among the set of monomials which are expressed as the product with the literal and the numerical coefficients. So it is also the same procedure as finding the greatest common factor. So I will give you some of the examples here. So first example, what is the common monomial factor of 2x and 3x? Okay, so we find this, the greatest common factor of the two monomials 2 2x and 3x are also the same with the procedure. So what we're going to do is to rewrite the 2 by 2 monomials here. So we write as 2x and 3x. So this is same procedure. Next thing to do is to express as the product of their numbers with literal and the numerical coefficients. So 2x which is expressed as the factor form of the numerical coefficient which is 2 times the literal coefficient which is x. So the factor form of this number 2x which is 2 times x. How about 3x? So it is also the same manner with the first number. So 2x is 2 times x, then 3x is also 3 times x. Okay, so is there a common of these possible factors of two numbers? Of course, yes. So here is the common with that the literal coefficient x. So now, what is our GCF or the CMF rather? We have the x right now. So our CMF or the common monomial factor which is x. Did you get it, students? Another example for number 2. How about we're looking for the common monomial factor of AC, AD, and AE. So we are looking for the 3 common monomial factors of 3 monomials. So it has very easy to do. So very easy to identify. So you should not express as a factor form. Instead of that, we are double check if what is the common among these 3 monomials. So what do you think? What is the common among these 3 monomials? Alright, so there is a common with variable A. So variable A, AC, AD, and AE. Thus, the common monomial factor which is A. Did you get it, students? So it is very easy. How about the third example? We are looking for the common monomial factor of 2AD. The second monomial is 4BC, and the third monomial is 6AB. So first, we have to going to rewrite some of these monomials here in order to express as the factor form. So 2AB, 4BC, and 6ABC. So this is the same as the process. So we are looking for to express as a prime factorization form if there is a numerical coefficient. So express 2AB, it becomes only 2. So the 2 is a prime number. So it becomes 2 multiplied by A times B. Next, how about 4AC? So since 4 is a numerical coefficient and it is not a prime number, so we're going to express into prime factorization. So the prime factorization of 4, which is 2 times 2, multiplied by, so times B times C. How about the third monomial, 6ABC? So 6, which is the numerical coefficient of the third monomial. So, and obviously it is not a prime number. So express into prime factors, which is 2 and 3. So 2 multiplied by 3 times, the remaining here is A times B times. Okay, question. What are the two numbers, or what are the numbers and variables that are common among these 3 monomials? Alright, so there is a common here. So among these 3, they are all common. So 2 and 3 is not. Even though there are 2 A's, it's not also a common because there is no A on the other monomial. Only B is also common, and C is not because otherwise the first monomial has no C common here. Thus, our common monomial factor, which is the box here. We have the 2 and b. So expressed as the product becomes 2b. Thus, the common monomial factor of these three monomials, which is 2b. Okay, this time we will have our another example. How about we are looking for the common monomial factor of a to the big power b cubed and a squared b raised to the power of 7. So, in order to us to find the common monomial factor, so we have to express by its own factor forms. So, if you're doing this exponent, so let's start with the first monomial. So, since a raised to the power of 8, it could be repeated as a product. So, in factors of a to the 5 becomes only 5 a's here. A times a times a times a times a. And b cubed is also b times b times b. How about the second monomial? The second monomial is a times a. And we are 7 b's here becomes b times b times b times b times b times b times b. Okay. So now, we are going to do is to cross out the commons here. So we have also a, another a, so no commons here. How about b? So there is also common with b, so there's 1, 2, 3. Okay, question. How many a's that are common are there? Only 2, so only 2 there. So right now our C and F, which is 2 a's, becomes a raised to the power of 2 times, there are only 3 b's here, it is also expressed in exponential form, which is b raised to the power of 3. So a squared multiplied by b cubed is also a squared b cubed. Did you got it, students? And that there is another shortcut to do to finding the C and F of these two numbers. So I will erase some of these factor forms here in order to us to get their shortcut method. Since we found out that your common monomial factor is a squared, so by comparison of these exponents in every variable, so between a to the 5 and a squared, so we get a squared. And for b, so since the b cubed is one of the part of the common monomial factor, so we get b cubed. So b cubed on the first monomial. So students, what did you notice about these circled variables here? So we discovered that we're finding the common monomial factor by finding the GCF of this literal coefficient by means of getting the lowest exponent of these stick variables if there is a common. So since we compare 5 and 2, so we get the lowest exponent is 2. And we compare 3 and 7, we get the lowest exponent. So all the circles that are expressed into prime number into product, so a squared and b cubed, it becomes a squared b cubed. So it is very easy to use the shortcut method. And last example, 24 x raised to the power of 2, y to the power of 5. Second one is 36 x6 y to the 4th power, and 72 x to the 4th power y cubed. So expressed as a factorization form of these three monomials. So let us start with the first. So since 24, it is a numerical coefficient of that, so we are looking for the possible factors. So the possible factors are, so 24, it could be divided by 2 is 12, so it is also 2. So 12 divided by 2 is also 6, it could be divisible by 2. 6 divided by 2 is 3, so also divided by 2. So 3 is divided by 2 cannot be. So proceed to the next prime number is 3. So 3 divided by 3 is also equal to 3. 1. So that is 2 times 2 times 2 times 3. So we added x squared and we added also to the big number. Next, how How about 36? So 36 divided by 2 is 18. So divided by 2. So 18 divided by 2 is 9. So exactly. So also we added 2. 9 divided by 2 cannot be. So proceed to the next prime number, which is 3. So 9 divided by 3 is 3. And 3, it remains as the prime number. So we added by 3. So 2 times 2 times 3 times 3 added by means of the variables and with exponents. So x to the power of 6, y to the power of 4. How about 72? X to the power of 4, y cubed. So we are looking for the prime factors of 72. So same procedure as that is 2. So 2 divided by 72 from this number is 36. So 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 2 cannot be. So proceed to the next prime number is 3. So 9 divided by 3 is 3. So 3 divided by 3 is 1. So 1 is a quotient, so no need to express. Then copy this exponents with variables. So y raised to the power 4 and y. So now let us determine the commons here. So all cross out these commons that are among of these 3 monomials. So there are 3 2's. There is a common. The second 3 2's there. How about this one? So it is not. How about this one? So these are on the bottom here. So 3. How about, there is only 3 there. So it is not included. How about the variable x? So since again the variable x, we are looking for the lowest exponent here. So what is the lowest exponent among its x variables here? So the answer is 2. So we get x squared as the lowest exponent. How about the variable y? The lowest exponent for variable y is 3. So it becomes y cubed. Thus, right now, our common monomial factor, which is expressed into the product form, which is 2 times 2 equals 4. 4 times 3 is equal to 12. 12, copy, paste, becomes x squared y. Did you really get it, students? So, I hope, students, that did you already learn all of these things to do that they are need to prepare for this lesson for mathematics grade 8. So it will help us to learn more on the preparation of the first lesson in mathematics subject. Thank you very much for our watching and listening. Keep safe always on COVID-19 pandemic, and God bless us all.